am Alan C. Smith. I am a consulting software architect. As you just heard, I have been writing LabVIEW for 34 years this summer. I am the old guy in the room, okay? I like being the old guy in the room, it's actually really cool. I am also LabVIEW champion, certified architect, et cetera, member of the Active Framework Guild. I'm doing this presentation to prove to people that I can in fact do a presentation on something other than Active Framework. For those of you who know me, that's they can attest to that. And I'm here to talk to you, not about Active Framework, but about classes. This is a class act. I am going to talk to you about a few simple design patterns, a few very basic ways to use classes that are kind of standalone, that you can pull into your applications and make your lives better, which is the whole point of any sort of these productivity tools and techniques and so on. Making our lives better as software developers. So we have had LabVIEW classes. We've had LabVIEW classes in the language since 2006, and we have classes in LabVIEW since even before then, if you want to go back to some earlier toolkits. They are everywhere. Our major frameworks are built on classes. DQMH is built on classes. You don't see that if you're working with a DQMH module. It's all under the hood, but it's built on classes. Active Framework, built on classes, and unlike DQMH, explicitly class-based and invites you to use your OO knowledge to build Active Framework systems, okay? They are everywhere. They are everywhere. We all know what this is. That's classes under the hood. A whole class design under the hood that makes that run. So if they're everywhere, how many of you are using classes currently in your code? Oh good, a fair chunk of you. A number of you are not raising your hands, and I'll bet I know why. This is one of my projects, one of my heavily class-based projects, and I will confess to having learned a lot from building it, and I would do things a little bit differently now. But that's a whole bunch of classes to make the application go. It's a wall of classes that you might beat your head against trying to understand. Because the reality is that object-oriented programming, how do I make a class? How do I inherit from a class? How do I override a method? Okay, how do I have two classes interact? The programming is straightforward. Design, not so much. Design is a hurdle, right? You have to learn how to do that. And for me, it's been a long road over my whole career. Most people have some level of hurdle before they get really comfortable with doing this, and that's a burden. We teach people in the object-oriented class, LabVIEW object-oriented programming and design and programming in LabVIEW. I can't even remember how the acronym is pronounced. I teach that class, I've advised on that class. We tell people start small. Use a few classes here and there till you get the hang of it, and then you can grow up, build on that knowledge. The beautiful thing about starting small is you can choose to stay small. If you don't want all of that, maybe I can give you a few classes, a few class designs, a few patterns that you can use and see improvement in your work, and that's good enough for you. And you can go on and write the code that you know how to write. But I can make your life a little bit better. And that's what I'm here to do. So we're gonna talk about these four: aggregation, state pattern, template method, factory method. Okay, and we're gonna talk about what they are, what they're for, how you use them, how you write them. Before I do that, what is a design pattern in this context? We call this a design pattern in LabVIEW. Incorrectly, in my opinion. This is not a design pattern, this is a template. It's a very useful template. I've used it, this happens to be on my own personal one, in fact, or something like it, that I've used in the past successfully. But it is a template, it's a piece of code, an actual code artifact that you can take and copy and use or recreate. That's not a design pattern in this concept, that's a template or something similar. A design pattern, that concept in our industry goes back to this book, 1994, Design Patterns, Elements of Reusable Object-Oriented Software by Gamma, Helm, Johnson, and Vlasidis. It has been revisited by other authors several times. I'll have another recommendation at the end of this presentation. I have this book on my desk. I recommend it. It's kind of a dictionary, right? There's like about 80 pages that you read to get the idea, and then the design patterns afterwards. And it's good to get more text on what they do, but this is where we started. These guys, these four gentlemen, looked at our counterparts in structural architecture. Here's a fun little fact. And the structural architects have, and my daughter's studying structural architecture, it's really cool. We have this overlap in what we talk about. Structural artifacts look at things like, how do I move a large body of people through a space efficiently? That is a problem that is repeated in buildings all over the world, okay? Certainly, you go into a building and you recognize certain spaces and what they're supposed to be. And it's not that they have a blueprint for what a hotel lobby should be, but they have a pattern for how stuff is supposed to move, and the architect takes that pattern and sits down and draws something, designs something that actually fits. That's what a design pattern is. It's a way to think about the problem, to shape and structure the problem, and if you implement the solution in a certain way, you're adhering to that pattern and you get that pattern's benefits. That's what a design pattern is in this concept. So you're learning some concepts here. With that in mind, pattern the first. Aggregation pattern. In my mind, not so much pattern as why we have classes in the first place, is what classes are supposed to do. Problem statement. Fake data, real customer. Okay, so I'm not giving anything away. I have a customer, they make crystal oscillators. I had this customer for years, right? And they have testers with a bunch of crystal oscillators in them that they're running long-term, sometimes just a couple of hours, sometimes days of testing on their crystal oscillators. And my customer wanted to see, for any one or two oscillators, the last hour of scan data. The last hour. I want to pull up a graph, see the last hour, and a moving average of the moving window of the last hour. Well, as I said, you might have 40 of these things. We're not putting 40 screens on, we're not putting 40 of these little panels on one screen. There's no room. Right? So we have very few displays. And I want to emphasize that I would like to have, but do not have, a database that I'm writing to that I could just query and get the last hour, right? I don't have that. Wish it did. We haven't gotten there yet for reasons outside the scope of this presentation. So I had to cache this hour's worth of data for all 10 or 40 of our DUTs. Well, we know what that cache looks like, right? We all know what a circular buffer is. Who's heard of a circular buffer? Yeah, most of the room, right? Okay, cool, I can kind of speed through this slide. This is a simple example. I have an array of 10 elements. I start writing and I have an index of what the last thing that I wrote to. And so initially my index is at 0, and I write my first data point at index 0 and the value is 0, and I start writing data points and I increment the index. When I get to the end, when I've written the 10th point and I'm going to go write point 11, the index goes back to 0 because that's where I'm writing to, and I write the 11th element. So when if I want to go say, give me the last 10 elements, I have some code that does the math that takes 9 elements of the one element and goes, and gives me my last 10 elements as an array. We have these, they exist. The chart has a circular buffer in it. We use them all over they're buried under the hood in DACMX. They're everywhere. Standard thing that we do. I first learned about them as a young developer in LabVIEW graphical programming. This is the latest version. I learned about it in the first version from 1994 by Gary Johnson. This book is so old that it came with a floppy disk with code on it. So my very first circular buffer came to me on a little floppy disk. I still have it somewhere, I think. Yes, I am that old, like I said, 34 years. And Gary Johnson introduced me to the idea of a circular buffer as a young developer. And he implemented it in his book, and it was on the disk, as a functional global variable, which we all know about, I hope. The new kids aren't being taught circular buffers. Or not circular buffers, they're not being taught functional globals. I don't know why. Right, and it looked like this, right? And it was a cool little VI that did exactly that. And it had it was an array, it was a scan of however many, 10 or 47 elements, and it would write those scans out into this two-dimensional array, and I had an index, and it would go do the calculations on the array when I wanted to read back, and it worked great. But you only get the one, right? In your application. In 1994, that was fine. Now, not so much. Actually, very quickly we found out that that only having one was a limit. What did we do in 1994 and 1996? We made a copy. So I had like buffer 1, buffer 2, buffer 3, buffer 4. Well, that kind of sucks. The other problem with it is it does, since you can write to it in one place and read from it from another, that's kind of the point, it obscures data flow. Doesn't take data flow away, but it kind of obscures it. Undesirable. So around the time, some of the first things I did in classes was I said, I want to do something else. So maybe what I want to do instead of this FGV, if I want to use this code in several places, is let's unroll it, right? And this is what that same code would look like if it was a simple sequential process. I'm going to initialize my array and my timestamp, I'll set a timestamp array, which is cool, and my index. When I want to do a write, it looks like this. When I want to do a read, it looks like this. And I could naively just take those code snippets and litter them throughout my application. I think everybody in the room realizes that that would be a very foolish thing to do. We're all here, we're all decent programmers. So we're gonna wrap those suckers up in VIs with a cluster that we pass through, right? Everybody's gone through this evolution. Okay, that's cool. That works, except, is there ever cause to directly write to my buffer index? No, that should only update when I write a new scan. Is it ever useful to read the 2D array of data as its own thing without doing any math on it? No, because I have no idea what the actual waveform is. Okay, you know to do this. You know not to do these things. You know these are terrible ideas. Does the intern know that? Might not. We would like to enable that person, that intern, that new guy, to be successful by denying them the ability to misuse the data. And that's where we get into classes. There is a document, white paper, that was released with LabVIEW classes in 2006 when they released our by value, not by reference classes, and they knew people were gonna complain, and I was one of them because, wait, this is not what I was taught how classes should work. And they laid out in that white paper the thinking behind why LabVIEW classes are the way they are, why they're chief among them, why they're by value. This nugget is in that document. You can still find it, it's still online. For those who choose object designs, we want wire and node to morph naturally into class and method. When you're looking at your application and you want to go turn it into classes, you're looking for those clusters of data that have VIs that go with them that you might put into a library. That's a class. So I still have the same VIs, but I've wrapped the data up in this class object, and the class is the thing that I pass around, and you no longer have the ability to directly manipulate the data in the data structure. And that is what an aggregator does. Right? There it is. There's my aggregation class, my aggregated class for a circular buffer. There is its private data. You can only access the private data through the methods. The methods, I have a few extra ones in here, but there's initialize, that should look familiar. So should the write, so should the read. Okay? That's what an aggregation pattern is. Right? We treat our data structure, our complex data structure, as a single object that we can pass around our system, a single atomic object, because it is a single atomic thing. And then we enforce rules for the manipulation of the data. We do not allow you to break them. That's for your safety. Benefits of doing this: we protect the data integrity. We guarantee that we only access the stuff the way we deny that tribal knowledge of how to use this code correctly. We build that into the code. We hide the implementation from the users. I've been walking around with that circular buffer class for, 3 decades? 2 decades, well, 2 decades, because that's about when I turned it into a class, was 2 decades ago. And I've changed it a little bit over time. You'll never know if you use my API, because it's buried behind the API. This makes it very easy to use, it's very obvious, very clear what I'm supposed to do, and it promotes reuse. I use it again and again and again on multiple projects. And of course, our first instance of reuse is unit testing. I think this is probably, for me, one of the biggest immediate benefits I get from OO is I can take my code apart into these discrete modules and I can write tests for them. And when I put them together, I get less bugs because I know the components all work. If you want another example, something a little more recent, for a project I did a few years back, I needed this is for they had a sequencing tool, and I had to be able to say I had a variable that was of a certain type. So I had to be able to give them a way to go look they had variables available in the system. I had to give them a way to go look those up and filter to look for certain kinds and so on and whatever. I needed to have a repository for these variables, a searchable, filterable repository. And I talk about this in a GDevCon NA presentation. I'll say more about GDevCons in a minute. Called Maps, Sets, DVRs, and Classes. And you can find that video online if you're interested in how I solved this. And I really did use a bunch of stuff. I had a complex data structure involving maps, sets, DVRs, and classes that I buried inside of one of these aggregate patterns. In doing so, I was able to use this variable repository. Here it is in just a Q-driven message handler like we're all used to working with. And it's just a piece of data that I can manipulate. This is a whole lot easier to read than if I had the complex data structure and I had to manipulate it the whole time. And I get to treat the whole repository as a single piece of data. So I can do something cool like add. I can define an add function. How do I add two repositories together? What are the rules for that? I made a VI that does it. Sets in LabVIEW, if you're familiar with those, and if you're not, you should be. They're not LabVIEW classes per se. We can't manipulate them like a LabVIEW class, but they're very class-like in their behavior. We have set math. How do I make the union of two sets? Or the NAND of two sets, right? I can't even remember what all the set math is called, but it's cool. And that's what aggregation lets us do, is we can treat it as a single thing and we can define additional functions for it. I can make a complex data structure out of my complex data structures. So here I had a customer who needed to have an event log and needed to fix the size of the event log because the test ran for days. And after days of building up his event log, LabVIEW got sluggish and eventually crashed because the event log was a big memory leak. So we fixed the event log size by saying I can treat a string as an unsigned 8-bit array of unsigned 8-bit numbers. I can fix that to be 100 characters, right? And then I can have 1,000 of them, and I fixed the size. Well, we had a symbols buffer that went with it for different symbols associated with different events, and so that's another circular buffer. That's a single unsigned 8, right? And then some additional information about how those two buffers interact with each other. And I've made a whole new complex data structure, which I can just manipulate in a way that we would expect to. I can write an event, I can read an event back. If you are an actor framework person, do I have an actor framework person in this room? I got a couple. All right, cool, awesome. If you know about the actor hierarchy inspector, that tool will show you basically the tree of your running actor system, and you can open up block diagrams and front panels and so on, and it's a handy tool. And lo and behold, there's an actor aggregator inside of that tool which gets information about the actors and stores it in an aggregator to allow me to have easy access. And there's a couple of maps in there for navigating around in my stuff. There you go. Start using these. Your life will get better. Next, pattern. Pattern the second, state pattern. My personal favorite, just from how I like to play, when I'm playing with these ideas in my head, I love state pattern. What does this solve for us? This solves the problem of, I'll give you, actually, I'm gonna drink a little water here, because you gotta hydrate the presenter, and then I will tell you about the problem. This is, again, from a real project of mine. The details have been changed to protect the innocent and intellectual property. I was tasked with, I have a controller, controlling some hardware. And we're removing big rods around. And I needed to be able to talk to this controller, and I needed to be able to manage its communications. And That was an actor framework system. I'm going to show it to you with a queued message handler for the sake of clarity. So I would have to do things like I need to connect to my instrument. So I had a case that was, go to connect to instrument. And it would reach out to the instrument and open up TCP communication. And then once that happened, I could expect that the instrument would say, oh yes, we are connected. And when I got back a connected message, I expected to be able to tell the controller, prepare to run for the day. Straightforward stuff, except I only wanted to handle, if I got an extra connected, which for reasons I can't recall at the moment, occasionally happened, I did not want to send a prep to run again because that would reset everything. That would be terrible. So I only want to prep to run if I'm coming from disconnected. So now I'm tracking state. Am I connected? Am I disconnected? And if I'm disconnected, then I'll send prep to run. Or if I'm connected, I'll do nothing. So my logic's gotten a little more complex. Awesome, great. At some point, after connection and after we've done a few things, I might receive a return to slot message. If I receive a return to slot, I should send store rod. But only if I'm in a state called ready. Wait, I hadn't defined ready yet, right? So I better have a way, I better be able to get a message back from the controller that says, I'm ready, so that you might get a store rod message back. So now I need to actually do state transition. But don't go to ready if I'm already in ready. And you see where I'm going with this. If you build up complexity, it can get really gnarly in terms of the code that you put in the block diagram. I talk about GDevCon in this presentation a lot, apparently. So GDevCon North America 2021, the first one, there was a presentation, and it was kind of a showdown between Norm Kirscher and Darren Nattinger. Norm, like me, loves behavioral state. Darren solves the problem in a different way. They had a little showdown. So you can figure out what worked for you. Norm's solution to state is a queue-driven message handler that looks like this. He calls it top-level baseline. You guys might have seen it, might not. I don't know how much traction it gets these days, but he was still talking about it in 21. And it manages state, and it does it effectively. But I'm looking at what he had to do to make it go, and the whole time I'm thinking, that would be so much easier if you just use a state pattern. What is state pattern? State pattern allows an object to alter its behavior when its internal state changes. The object will appear to change its class. In other words, if I have a queue-driven message handler and I send it a message and I'm in this state, I'll get this response. When I change states, if I send a message, I will get a different response. It is like I'm talking to a different queue-driven message handler. Okay, so how do we implement that in LabVIEW? Good question, you ask. Going back to the white paper, there's another place where they're talking about what is a flag that you want to be thinking about dynamic dispatch, where I can make a child class that changes the behavior of the parent. And what they say is if you're looking at a cluster of data and the cluster of data has an identifier in it like my state here, connected, disconnected, and that identifier exists only to tell you what to do with the class data at certain points in your code, like it's going to wire to a case structure in several places, then that cluster data, because clusters are classes, that cluster data and the case structure become a class with dynamic dispatch methods. So instead of having that am I connected, am I disconnected, am I ready case structure inside of connected, I have a dynamic dispatch VI. Are you all familiar with dynamic dispatch VIs? I'm getting a couple of shakes of the head. So for the folks who are shaking your head, if you make a class, you give it a method. You can say, this method is dynamic dispatch. And what I say when I do that is you take my class and you make a child of my class. You inherit from it. And then you can say, I want to change your method in some way. I want to add to it or I want to replace it entirely. And so you can make a VI of the same name. And when LabVIEW gets to that spot in the code where you're calling the parent class method, LabVIEW will go, I'm using this gentleman's version of the VI instead of mine. That's dynamic. It's a function swapping. Very efficient function swapping. So that's what we do. We just set up some function swapping here. That dynamic dispatch VI is doing the same job of the case structure in all the cases. And then I just have one of those VIs for every place I have one of those case structures, right? I make a parent state class that is some data that I want to carry around, and all of the things that I expect to do that depend on state. And maybe some other things are in there too, depending on need. And then I go and I create these state-specific responses, right? So if I have prep to run and store rod as two things that maybe I do prep to run when I'm disconnected, I do store rod when I'm ready, a couple of states that I'm in, right? Those are the things that I expect to change. Those are where I would have that case structure that I talked about. That's fine. I make child classes for my specific states, my idle state, which is my disconnected, and my ready state. And then you will notice that idle has prep to run and ready implements store rod. That's the simplest case where I have things that I only do in one state or the other. I could have, ready might maybe get, maybe if it does, maybe when ready gets a prep to run, what that does is sends a message, right? So it says, hey, I'm already ready. I don't need to do that. But you get the idea, right? You build into that whatever complexity you need. So going back to my original problem, when I'm initializing, that's the equivalent of entering my initial idle state. So I have an entry VI, and that does, what do I do in entry? Connect to the instrument. So now I'm connected, I prep to run, or I get the connected message back, and when I get to connected, I go, oh yeah, I'm supposed to do prep to run. If I'm idle, I implement prep to run, which sends the prep to run message. Okay, cool, right? If I get return to slot, well, I'm in idle. Idle doesn't know how to return to slot. That's not appropriate, so I do nothing. Whoops. So I do, hello. I do nothing. Make sense? So what happens if I'm idle and I go to ready, right? I get the ready message. I am ready. Okay, I need to change to ready so that I can receive the messages and handle the messages that I get when I'm ready. How do I do that? That is just a little bit of complexity. This is the connector pane for my go to ready method. This is the thing that I do when I get the ready message back from the controller. You will notice if you have seen classes at all, you know that that is dynamic dispatch. That means that that's a dynamic dispatch VI. Most of the time when you're doing dynamic dispatch VIs, you expect the output of the class to also be dynamic dispatch. Yes? Not in this case, not dynamic dispatch. What does that mean? That has a specific meaning in LabVIEW. If I have dynamic dispatch in, dynamic dispatch out, I am telling the compiler that the object that passes in, this is where class and object are different things. The object, the specific thing at that spot, on the wire at that spot, is the exact same object that I'm going to pass out. And that imposes certain rules on what I can do on the block diagram because they're only because I'm restricted if I want to make that be true. If I say that I'm outputting a class, and it could even be the same class, but it's not dynamic dispatch, I'm telling the compiler that this object coming in may or may not be the same object that goes out. And in fact, if that output is a parent class, all I'm saying is that, yes, I had this object going in, and I'm going to pass out an object that is of the same family as the input. It's just data coming out, or that data can be anything. And that lets me do this. This is the block diagram of that VI. I'm in idle. This is the idle go to ready. I'm in idle. Idle comes in. I throw idle away. I return ready. That is how I do a state change. So now on that wire on the queued message handler, where my class sits, I now have a different class. A child of my state classes. It's the same family, but it's a different class. Now we're not done here. Idle has some attributes with interesting values in them that I probably want to preserve, like the address of the controller that I'm talking to. That might be something I want to carry around and not throw away. This is just a default instance of the class, and it doesn't have the value. Yeah, default instance of the class, default object, default values for attributes. No data. I need to do a transfer. I need to move data from idle to ready. So I have a VI that swap attributes. I probably should have put a circle around it right there. You can see it, idle and ready, both wire and swap attributes. What is swap attributes? That is a VI that, because it is a member of that parent class, it is allowed to access the private data of both of those objects. It's allowed to do that. They are of the same family, so it can get at the level of a state, it can go get all that state data and move it over. The state is the parent class, recall. So that's how we do that. Now, it took me more years than I cared to admit to recognize that there's a bit of a workflow hazard here. If I go add a new element to my attributes, new attribute to my cluster, I have to update this. But there's nothing in the compiler that will tell me to do that. So I have, on many occasions, added an item to the cluster, to the class's private data, and then go on about myself. And I'm like, why am I not getting this data through to my classes? Oh, you knucklehead. Go back and add the thing here. To the point where I started doing things like I put a big note on there saying, remember to update swap values. And then somebody pointed out that what I could do is I could just put all of the values I want to persist from state to state to state. If I put them in a cluster and I call it persistent, I can just do that. So do that, please. Let me, learn from, let me be your cautionary tale. I'm perfectly comfortable being your cautionary tale. Do this. That makes it so that you just get that update for free. Returning to my example, this is again return to slot. Now I know what to do here, right? So I got return to slot back. At some point I got a ready, and at some point I got the ready message. I've gone to ready, I've transitioned. Now I know what to do with store rod, which is that code. Cool, awesome, done. Everybody with me so far? Here comes your summary. Why do we do state pattern? So state pattern, and this is what I wound up with. I wound up with 3 states, and I had messages that would make me change. You can see if I got a ready message, I went from idle to ready. Idle would send me from nest inhibit or back to idle. So these are the allowed paths between states implemented with, you can see I've got a go to idle and a go to ready and nest inhibit. Nest inhibit idle just had the go to ready. You can see that I had methods that supported all of those things. I have simpler block diagrams. The message handler is just message handling. When I get this message, I know I'm going to tell the state to do a thing. What the state going to do? I don't know at that block diagram level, but I know it will do what are the things that it's allowed to do. The states themselves, what do I do when I get a go to ready? Oh, okay, I do this thing. I know what to do there. I can look at that separately. I can say, in this state, I do these things. I don't have to worry about message handling right now. I know that's handled somewhere else. These state classes are individually testable. I can take them out of the queued message handler and I can poke them and make sure they do the thing they are supposed to do. When I need to add a new state, did I talk about nest inhibit in the last 15 minutes? No, I just added it because I needed to. It's easy. Make a new child of my parent state, populate it with what the message is supposed to do, done. It's gonna work in message handling, right? You get that for free. Some of you may complain. Maybe you not, you guys are all cool. Some people have complained that they want to know what's going on in store rod here. They don't see it. They want to see that case structure so they can click through all this stuff and see it. Well, you can still click through and see this stuff. For many, many years now, if you double click on a dynamic dispatch VI, which is no more difficult than clicking through cases to the one you want, you get this wonderful dialog box that will show you the block diagram of every VI that you can call at that location that is loaded into memory. If you got a plugin architecture, you got to go somewhere else. But if it's all in your project, you get to see them all. So no excuses. So this was the instrument controller when I got done. As I said, it was an actor, not a queued message handler, but actors are queued message handlers. It had that state-based class. It had my 3 states when I was done, right? If you know UML, you know what this diagram looks like. What's that? What is that? That front end, FE is for front end. FE base inherits from something called state object, which is a class I hadn't talked about before. That leads me to my third pattern, template method. Remember my problem statement. Remember all of these things that I could do, right? The connect, the receive connected, receive return to slot, receive ready, et cetera, et cetera, et cetera. Some of these things are transactions. I am in a state, do a thing. Some are transitions. Oh, I was told to change my state. Cool, I changed my state. Some of them are, this one was an entry action. Going from idle, or going into the idle state, going from idle to ready, I might do a thing. In this case, connected instrument was a thing I did entering the idle state. And you can see these represented, right? So what I need is I need a way to define doing that all the time. How do I do that every single time I change a state, right? And what I actually, so I have these transition operations, right? I do entries. I also remember I have to swap those attributes at some point, okay? And this is actually what that state object does for me, is it lets me define a change state algorithm. What do I do when I go from idle to ready? Okay, I'm exiting idle or any other state. I'll use idle as an example. I exit idle to ready. I'm going to do all of my exits. I have activities defined for idle that when I leave idle, I'm going to do. That happens in exit, a dynamic dispatch VI that I define for each of my classes. Swap attributes, dynamic dispatch VI that lets me move the data from idle to ready. Then I go into ready and I do ready's entry, and that's another dynamic dispatch VI, right? Well, 3 dynamic dispatch VIs defining behavior as I go through this algorithm. The algorithm itself, this is something called change state.vi that is not dynamic dispatch, that is fixed. That is the VI that I actually call when I want to go from, in this case I'm going from something to, I'm going idle to ready, for example here. That's what that looks like, that's what that code looks like. Change state is fixed, the algorithm is fixed. I will exit, I will swap, I will enter. What I do at each of these levels, each of these things though, is defined by the classes in question. And that is template method. It doesn't apply just to state pattern, it applies to a lot of other things. Define the skeleton of an algorithm in an operation, deferring some steps to subclasses. Template method lets subclasses redefine certain steps of an algorithm without changing the algorithm structure. The algorithm is fixed, exit, swap, enter. What I do on each of those steps depends on the classes that I'm playing with. That is what template does for us. That's a bit of reusable code, by the way. I've used this on a bunch of projects. It's just and that's another example of reuse. I have a parent class, I inherit from it, I do stuff with it, off I go. You can't quite get this yet. I have some work to do. But you can get something very, very close to it if you download NI State Pattern Actor from vipm.io, because I do this very slightly differently. There's a way to do it that's optimized for actors that's in there, but you can go get an equivalent class and you can change who it inherits from, and you can make it be a state object for non-actor classes. I do intend to add the non-actor version of that to this package because sometimes you don't, for various inheritance reasons, it's useful to have both, even with actor framework. Another example this is the customer with the big project I showed you at the beginning, the crystal oscillator guy. A lot of that is a harder abstraction layer. He's got a ton of instrumentation that he wants to be able to swap out. Those instruments all come with config files. He has a specific algorithm for loading config files for devices, which is that, okay, I'm loaded this device, I'm gonna go get its config file out of this folder. Oh, no, it's not there. If it's there, I'll load it. If it's not, I'm gonna go get the default, which is stored with the class on disk. If I can't find a default, I'm gonna warn the operator that I don't have any of that, and we're using the class defaults, which are not even what's on disk. Load core is how I load a file applied to different files in different places, but this is his fixed algorithm for how he wants to load. Yeah, that's what he wanted. I wrote it for him. Actor framework itself heavily relies on template method. The actors have life cycles. Certain things happen at certain times. There are dynamic dispatch VIs that you can override to modify the actor's behavior. It is template method. Actor framework is template method plus command pattern. If you know those, you know how actor framework works. My fourth and final that I'll talk about is the factory method, which has a little bit of similarity with template. So that part of the reason I showed that last example is that I do have this hardware abstraction layer. And this customer wants to load instruments at runtime, specific instruments for the specific test at hand, one sequencer to rule them all, but customized by changing out the hardware. So how do we instantiate those objects? How do I load those pieces of hardware? Because they're all represented by classes. How do I load those specific hardware classes into memory? Well, if you know for a fact that I only have a handful of instruments, I can write something, pretend that array of enums is actually an input to this VI. But I can input into this array of enums, and I could go to a case structure, and I could go pick the specific instrument that I want, and then I can pass it out, and I can load its configuration token and go on with myself, right? That's great if you're just getting started. In fact, typically that's what you'll do when you're just getting started, or if what you're doing is writing simulators, right? I've got a closed set of simulators, right? And so this is a simple factory. No, it's a hardware abstraction layer. I actually want it to be a plugin architecture, and this is what we did. I go off to an INI file, I read all the instruments that I'm supposed to have today, and then based on that, I load the LabVIEW class into memory from disk, and then go and I load up the token, okay? That's another way of loading these instrument objects into memory. What if I want to choose one or the other? Like I said, I have a closed set that I use for instrument simulation. I want to go back and forth between them. How do we do that? It's actually kind of like factory. It's kind of like template method. In that, I say, cool, I'm going to make a parent class called factory. It has a VI called getInstruments. It's dynamic dispatch. And then I'm going to have for the closed set factory, on the closed set load, for dynamic loading factory, I'll load from disk, right? And now, factory is a parameter. Remember that classes are data. I can pass them around like a piece of data. So I can, that's actually what factory method, I'll show you that in a second. Back up real quick. You back, nope. Back, I say, back, nope. Yeah, so that's now a parameter. I can now pass a factory of one of these types into my application, and I will get one of these loadings depending on what I do. Factory method, define an interface for creating an object. The interface is, given this factory, call its getInstruments. That is the interface. But let subclasses decide which class to instantiate. Am I closed set? Am I plugin? Am I simulator? Factory method lets a class defer instantiation to subclasses. Turns out there's a spectrum of things called factory in the design pattern book. There's like 4 different possible flavors of it. This one's kind of far down on the list. This is not one you necessarily start with, but you will get here if you're doing any sort of hardware abstraction layer. That's what it looks like in implementation. Pick the factory I want, pass it into the application, call, get, instruments, do stuff, done. Template method and factory method put together are a hardware abstraction layer, which everybody wants a HAL, right? Who does not want a HAL? That's what I thought. All right, that's the 4 I was going to talk about. But I'm not done talking to you, because I will mention a couple of others that are worth looking up on your own time that I also use. Memento, those tokens. Mementos are also called tokens, those configuration tokens that I would show you loading. Without violating encapsulation, without sharing stuff about a class I don't want to share, capture and externalize an object's internal state, meaning give you a little basket with the state in it, so the object can be restored to this state later. I have a configuration, I save it to disk. I bring the configuration back. Undo. in any modern application works the same way because I make these little tokens of the operations that I did, and I have an array of them. And when I want to undo, I just go back up the array, and I go back to my original state. Proxies. I love me some proxies. I love proxies a lot. Surrogates are placeholders for another object to control access to it. A remote proxy is, I have a thing here that as far as my application is concerned, this class I'm talking to is the actual class, the actual piece of hardware. No, it's not. It's actually a bunch of TCP/IP code that connects me to the actual instrument running on this computer over here. That's a remote proxy. A protection proxy is, I want to let you use this resource, but only in ways I'm going to permit you to use them. And so I write a little class around there that exposes just the subset of things that I want you to do, not the whole set. I use this all the time. Decorator. I have this class that I know that it works. I want a class that does a few additional things. So I take that class, I put it inside of a class, wrap stuff around it. Decorator pattern. You can look those up on your own. Homework. Those are what we talked about. Aggregation, state pattern, template method, factory method. Start using these, your lives will get better. They are easy, they complement each other, but they're easy and they're standalone. You don't have to have the big wall of classes to start using these. You can use them now. And if you use those, or even a subset of them, and they make your life better, and that's all you want to do, I will not come visit you in the dark of night. I've made your life better. That's all I'm looking to do here. That's the original book. This next one I have not read, but my good friend Sam Taggart, who has recommended great books to me in the past, has recommended this one, so I'm sharing that with you as well. You can go find that. And there's a ton of books on design patterns, right? The Gang of Four book is a textbook and it's a little dry. So you might find something that's a little newer, a little more, current take on the same ideas that might help you better. Who here has heard of GDevCon? Outstanding. We'll get the rest of you guys up to speed. GDevCon there's a series of, we have 5 worldwide. Like, wow. The GDevCons, plural, are user-driven events, community-driven technical conferences with content just like this. This was a GDevCon presentation by me from 2023, which is very popular. It gets, I redo it a lot because it's really useful for people. And you've heard me mention GDevCon a couple of times, right? I did another aggregator pattern that was really cool. The Norm versus Darren showdown was from 2021. That's the kind of content that you get at a GDevCon. NI participates as just another attendee. They don't run it. They do sponsor, and that's really, really cool, and we're really glad that they do it. And they don't run it. We run it, the community runs it. And that's really, really important because we can say whatever we need to say. So if you like this content and you want more of it, consider going to a GDevCon. I sponsor the US and European conferences. These are the ones I go to regularly. I present with some frequency. And I would encourage you to go check them out, right? And if you do go to Chicago in July, and you've heard about Active Framework and you're curious about Active Framework, anybody here curious about Active Framework? Okay, you would like to come to GDevCon. Because after GDevCon, the Friday after, right next door, physically right next door, I am running a hands-on workshop where you get to play with some hardware, yay hardware, and you get to learn a little bit about building systems in Active Framework, and that is targeted at people who do not have an extensive OO background. You don't really have to have an OO background at all. If you're Core 2, Core 3 level developer, if you know about queued message handlers, you will be successful in this workshop. About 3 to 4 hours with me in the morning. That's that little guy in the corner is my token from my other presentation, because I had the AF developer, the non-AF developer, and I marked my slides with who was who. So this is for my non-AF developers to come take this. Out in the hall is the GDevCon table, and you can come play with the solution to the problem I'm going to present in the workshop. And you can come check out the hardware we're going to use. If you want to buy a with kit hardware, I'll get you the little kits, right? If you have your own, you can bring it. But you can come play with it and see what it is you're going to build. And I can talk to you a little bit about that. Friday, July 24th in the morning, come hang out with me, come learn some actor framework. There you go. That's how to get hold of me. You can find me on LinkedIn. I am just ACS on the forums. If you see me on the forums, I post there from time to time. That's my personal website at the bottom. I have a card right there with the same information on it if you want to come grab a card. If you reach out to me on LinkedIn, tell me you saw my presentation because I get a million people wanting to connect to me. I've got no questions. Do any of you have questions? It's 12:20. We can hang out for 10 more minutes and talk. Uh-oh, Jeff's gonna heckle me. I know Jeff, he's a friend of mine. What's up, Jeff?
So the, what is it? I've forgotten the name of the pattern now.
First, second, third, or fourth?
The state pattern.
State, yes.
So that's kind of based on a kind of unique state. You can only be in one state, but
True.
It seems like everything I do, I always have like two states. Like you got to be initialized and user signed in, or I don't know, things that are not mutually exclusive.
Is that a matrix? Can you be initialized in 3 or 4 things?
Yeah. How would you handle that for something like that?
Okay, so I will upfront admit, that I have been told that this state pattern implementation is not as deep as you can go with state pattern implementations. It is an initial pass. So with that in mind, what I have done with this is I have actually had, so as long as if I can be initialized and it's not a case of I can be initialized or running and one of these same things, if you've got that matrix, that's gonna get, I'm not sure what I would do there. But if it's initialized and one of these, and none of these I can't be in any of these if I'm in a different one over here, right? If it's a one-to-many and not a many-to-many, right? I've actually made children of states, right? So maybe ready has a couple of child states where I'm, ready and primed, or I'm making up states, or ready and fired, right? I'm ready, but I haven't cycled yet. And so you have all of the behaviors of ready plus, okay? I've done that. The swap attributes gets exciting because you can have the child classes, the child states can have their own private data. Swap attributes gets a little exciting when you're doing that. Another thing that you might consider is really honestly, no, I have 1, 2, 3, 4, 5. And the other thing that I would consider is have kind of maybe base level methods that you do. Here are all the operations I can do, and here's an API of all the operations. And then I'll have all my possible permutations, and I will just call those VIs that do the specific thing in the state. Maybe so I have an API that's all the possible things the machine can do, and then I mix and match into the various state things. You ask a great question, because I don't know that I have an out-of-the-box answer for you. And I think you've asked me this question before.
Interfaces address that? The many-to-manys, like the interface?
Interfaces might help,
depending on if you want the data or if it's just...
Yeah, I haven't played enough with interfaces. The problem is that, this version, like I said, I drew from a way that we can do state pattern in Actor Framework that is kind of unique to Actor Framework. And in that one, you're doing some private stuff that's private to the actors, and the interfaces don't quite work. You have to make something public you don't want to make public. But there may be something there. Absolutely, maybe something there. I'd be interested. I would love to come to your presentation on how you've used interfaces to make state pattern better. In all seriousness, yeah. There's a lot to talk about in state pattern. Consider this a first approach. For what a lot of people do in queued message handling, oh boy howdy, does this make it better. And then you might get into your harder cases as things get more complex. So I won't deny that I haven't explored all of that. Good question. Next question. Anybody? Bueller? Yes, I am that old. Bueller?
Okay, so I'm an electrical engineer by training, but I program LabVIEW.
Yep.
I really enjoyed your talk, but a lot of it went above my head.
I'm sorry.
No,
I can help you if you want to talk some more.
I have a simple question.
Sure.
like in my program, I'm interested in implementing some object-oriented patterns to make it better and cleaner. Because I'm from Halliburton, some of the code can have a lot of glitches. So is that, do you think that's a good idea for me, or is that too ambitious? And if it is a good idea, then what's an easy introduction to object-oriented program?
Object-oriented design and programming in LabVIEW. That is available as a self-paced online training course. You don't have to come take it from NI. Well, it's from NI, but you don't have to come sit in a classroom.
On justacs.com?
No, it's an NI course. It's like $500. I don't know what the actual price is, but it's not expensive.
I have it available via my company. What's it called?
Object-oriented programming. Ask me after. It's a long name. It's the OO class. It's really obvious. It's the only one with object-oriented in the name. It's object-oriented design and programming in LabVIEW. UDPILV, I think, is what they call it, just because.
Object-oriented programming in LabVIEW by Alan Smith.
Design and programming in LabVIEW.
Okay, I got it. Thank you.
And I'll make sure you've got that right before you go. I would go there, and actually, this bit of lecture, there's a very similar chapter in the OO course, because they had me do. They brought me in as a subject matter expert to help advise on that course, and I'm like, you need to have like the simple patterns to get started. So this is actually reprised in there.
Thanks.
Yeah. No, and if you're doing a legacy application, some of those things like I've got a cluster of data and a bunch of methods that work on that. Well, maybe that's the thing I turn into a class, right? That's a good piece of advice. I have a cluster of data with an identifier in it, and the identifier gets plugged into several case structures to tell me what to do with my data, depending on what the identifier says. You want to do dynamics dispatch there, so maybe there's a class there as well. And so those are some of the places that you start when you're refactoring an existing application. And then, I do consult, so, I can come help you out on that. Got to make the shameless plugs, right?
I was just wondering if there's examples or training where you can actually step through building those different patterns.
Yeah, they're covered in the OO course. There's actually a chapter specifically on these, because these are the ones that I said, guys, you want to teach to these. And they have exercises for. The only one I don't think they do an exercise for. There's a couple they don't do exercise for. A couple of them they do.
I took the class.
I'm starting to put stuff in the community training initiative, and so you just told me that I need to put some stuff in the community training initiative, so thank you.
I took the class probably 7 years ago, so I don't know if it was in there.
OO's been revised.
Okay.
And like I said, it's self-paced online if you want it, or you can do it with an instructor. The instructor is obviously much more expensive. Going once. Oh, that gentleman.
Is there any favorite framework which I should use for distributed systems?
I'm sorry, run this.
Primarily wherein, let us say, a Cerio is running a critical application which controls a machine.
Okay.
And there is another piece of software running on the desktop which monitors it, sends the commands over the network. Now, naturally, they would manage the state by checking a heartbeat. But is there something specific that comes to your mind to say that this would be a favorite way of doing such things?
I'm sorry, one more time? At the end, the last part of your sentence?
Is there a favorite way in your experience to do or manage those kind of systems by borrowing from these frameworks?
Well, this was I was talking to actually that was a PLC, but it was the same idea, right? And so the PLC, which is not telling me its state data, was telling me what was going on, and based on that, I would update state on my desktop. Actually, it was the Compact Rio that was updating. That Compact Rio talking to a PLC, it was kind of weird. Yeah, and it's kind of situational depending on what you're doing. I'd have to talk to you more about your use case, I think, to answer your question.
So the use case is that there's a hazardous operation going on, which is being controlled by a Rio, and there is an operator interface on the desktop, which takes a command based on the feedback available of the state of the machine. Now, the state transmission would happen, and there would be heartbeats to know that the machine is operational or not, good or bad.
Yeah.
But from your experience,
Hold that thought. So, all right, I see everybody's like, yeah, I'm between you and lunch. So, if you want to talk to me, I think actually what will help with talking to you is getting the mic out of the way, because I've got a little bit of echo and distortion and stuff. So you and I will just talk. So I'm going to put a pin in your question. We'll come back to it, I promise. Anybody else before we break? Cool. Then I will take this gentleman's question without amplification.